Good morning, dear students, and welcome back after a break. I believe that you had a wonderful time. You also have completed your notes and assignments. Since we are continuing with online video lectures, so I'd request you to attend the video lessons regularly and complete assignments on time. If you do have any doubt, kindly message on Campus Care for clarification. Before the summer break, we already have started with Lesson 3 in Chemistry, Metals and Nonmetals, where a metal is a material that is typically hard, opaque, shiny, and has good electrical and thermal conductivity. Metals are malleable, fusible, and ductile. The physical properties of metals are hard and strong. Metals are generally hard, strong solids. They are strong enough to bear heavy loads. That is, they have a high tensile strength. We generally look for a metal when we need a strong material. This is because metals are in general hard and strong. Some examples of metals are magnesium, aluminium, iron, copper, silver, gold, etc. Here exist some exceptions. Sodium and potassium are soft solids which can be cut with a knife, and mercury is a liquid under ordinary conditions. If we compare this physical property to nonmetals, we can say that most of the nonmetals are gases, only a few are solids which are not very hard in nature. Metals have a luster known as metallic luster. For example, aluminium, iron, zinc, copper, silver, and gold are all lustrous. Such metals can be polished too. Metals are sonorous. When struck, they produce a sound called a metallic sound or metallic clink. Recall the ringing of a bell or clink of coins. Metals are ductile. That is, they are flexible and can be drawn into wires. For example, iron, aluminium, copper, silver, and gold can be easily drawn into wires. Can you draw a wire from a piece of wood or coal? No, because coal and wood are brittle, not flexible. Metals are malleable. In other words, they can be beaten or rolled into sheets. Aluminium, iron, copper, or silver can be beaten or rolled into thin sheets. Common examples are the silver foil used to decorate sweets and aluminium foil used to pack stuff, foodstuff. Metals are good conductor of heat, that is, they allow heat to pass through them easily. Due to this property, we use metal utensils in kitchens. Heat supplied at one place of the utensil is conducted all over it. We cannot use a frying pan made up of cardboard because it is a bad conductor of heat. When placed over flame or fire, cardboard does not distribute the heat all over the pan. Instead, it starts burning due to the localized heat. Metals are good conductor of electricity. That is, they allow an electric current to pass through them easily. This is why electricity is transmitted from one point to another through metallic wires like those of copper or aluminium. Silver is the best conductor of electricity. The next best is copper and then aluminium. We cannot use nylon or jute ropes for electrical transmission, as nylon and jute are bad conductors of electricity. With these physical properties of metal, we see their uses in different fields, such as iron is used in making machinery, buildings, car, motorcycle, ships, bridge, etc. Copper is used in making electrical wires, statue, etc. Aluminium is used in making kitchen utensils, electric wire, etc. Gold is used in making ornaments. Silver is used in making jewelries, ornaments. Now we will see chemical properties. Metals and nonmetals differ from each other in their chemical properties also. If we compare the chemical properties of metals with those of nonmetals, they are as follows: reaction with oxygen, reaction with water, reaction with acids, displacement reaction, and reaction with bases. Today we will see the reaction of metals with oxygen or air. When a metal is heated with oxygen gas, a metal oxide is produced. For example, magnesium metal produces magnesium oxide. Iron metal reacts with oxygen to produce iron 2 oxide as well as iron 3 oxide. This formula equation shows the reaction of iron with oxygen forming iron 3 oxide. The level of reaction with oxygen depends on chemical reactivity of metal. Some metals react with oxygen even at room temperature. Some react on heating, whereas some other react only on strong heating. Most metals react with oxygen. Some metals react quickly and some only react very slowly. Where we consider magnesium, it burns an oxygen with a bright white flame. When a metal reacts with oxygen, the product is a metal oxide, and this is called an oxidation reaction. Addition of oxygen in a reaction is oxidation reaction. The reaction between an alkali metal and oxygen also is an example of oxidation reaction, and we will take up the two examples here. First of lithium. Lithium reacts with oxygen and produce lithium oxide. Sodium reacts with oxygen producing sodium oxide. The reaction of lithium and sodium occurs at room temperature to form the corresponding oxides. Potassium similarly reacts with oxygen of air at room temperature to form potassium oxide. Lithium, sodium, and potassium metals are so reactive that they react vigorously with the oxygen of air. They catch fire and start burning when kept open in the air. In fact, lithium, sodium, and potassium are stored in kerosene oil to prevent their reaction with oxygen, moisture, and carbon dioxide of air, so as to protect them. Since lithium, sodium, and potassium metals react with oxygen even at room temperature, therefore, lithium, sodium, and potassium are very reactive metals. The metal oxides are of different forms and colors from the metals. If we consider magnesium oxide, it is white in color, aluminium oxide, white in color, zinc oxide yellow when hot, white when cool. Iron oxide, iron 2 oxide, and iron 3 oxide are dark brown in color. Lead oxide is black in color, tin oxide is black in color, copper oxide also is in black color. Reactive metals react very quickly with oxygen. Less reactive metals react slow. Non-reactive metals such as gold, silver, and platinum do not react with oxygen. The metals such as magnesium and aluminium react very fast in air with oxygen. Zinc and iron react with fast with air. Lead reacts moderately fast in air with oxygen. Tin reacts slowly and copper slow. These metallic oxides are basic in nature because they react with dilute acids to form salt and water. They also react with water to form metal hydroxide, which are alkaline in nature because these metal hydroxides release OH ions, hydroxide ions in solution. On the other hand, when we will study about non-metallic oxides, we will see that non-metallic oxides form acidic solutions in water, which liberate hydrogen ions in solution. Therefore, non-metallic oxides would be acidic in nature. The metal oxides, sodium oxide, potassium oxide, lithium oxide, aluminium oxide, magnesium oxide, these oxides are basic in nature. These will give hydroxides when react with water. This can also be proven by litmus paper test, where metal oxides when reacting with water will form bases and turn red litmus paper to blue. On the other hand, non-metallic oxides while reacting with water will form bases that turn blue litmus paper to red. So magnesium reacts with oxygen forming magnesium oxide, copper reacting with oxygen forming copper oxide, iron reacting with oxygen forming iron 3 oxide, as here the valency of iron is 3. The compound is also known as ferric oxide. When magnesium is burnt in air, it forms magnesium oxide. Burning in air means reaction with oxygen present in the air. Magnesium oxide forms magnesium hydroxide with water, and solution of magnesium oxide turns red litmus paper blue. This means that magnesium oxide is basic in nature, whereas some of the metal oxides are soluble in water. Most of the metal oxides are insoluble in water. Sodium oxide is in water forming sodium hydroxide. Calcium oxide reacts with water forming calcium hydroxide. Magnesium oxide reacts with water forming magnesium hydroxide. Are the metal oxides soluble in water forming metal hydroxides. If we consider iron 2 oxide or iron 3 oxide, copper oxide, these oxides of metal are insoluble in water. Amphoteric oxides. Amphoteric oxides are metal oxides that react with both acids and alkali to form salt and water. In that condition, the metallic oxide not only behaves like basic oxide but also acts like acidic oxide. Like, for example, zinc reacts with oxygen forming zinc oxide. The metallic oxide, zinc oxide, reacts with both acids as well as bases to form salt and water. In first case, zinc oxide reacts with hydrochloric acid in the diluted form to give zinc chloride, the salt, and H2O water. The reaction is neutralization reaction as we get salt and water. The acid is hydrochloric acid, hence the base present in the neutralization reaction is zinc oxide. This is the normal tendency of metallic oxide acting like basic oxide. But in second case, zinc oxide reacts with sodium hydroxide producing sodium zincate, the salt, and H2O water. The example is neutralization reaction producing salt and water. The alkali present or the base present in the reaction is sodium hydroxide. So for this situation, the corresponding acid is zinc oxide. Unlike other metallic oxide, zinc oxide in first case behaves as basic oxide and in second case behaves as acidic oxide. The second example is aluminium oxide. The formula is Al2O3. Aluminium oxide also acts as basic oxide as well as acidic oxide and is the example of amphoteric oxide. Aluminium oxide, when reacts with hydrochloric acid, gives aluminium chloride with water. In this condition, aluminium oxide behaves as a base, whereas in second case, aluminium oxide acts as an acid reacting with sodium hydroxide, giving sodium aluminate along with water and acts as an acid. So today we discussed the chemical property of metals, starting with reaction of metals with oxygen of air. We discussed the various conditions in which metals react with oxygen to form metal oxides. These metal oxides are basic in nature. Some of the metal oxides react with water to form alkalis. Some of the metal oxides, which are soluble in water, react with water to form alkalis, whereas most of the metal oxides are insoluble in water. The metal oxides, being basic, turn red litmus solution blue, whereas some of the metal oxides also react with acids as well as bases to give salt and water. Those metal oxides which show therefore basic as well as acidic nature are known as amphoteric oxides. Aluminium metal and zinc metal form amphoteric oxides, aluminium oxide and zinc oxide respectively. Thus, aluminium and zinc oxides are amphoteric in nature Amphoteric oxides react with both acids as well as bases to form salt and water. In next class, we will continue with chemical properties of metal and we will see reaction of metals with water. Thank you.